Hello children, today we will start our lecture from page number 190. First point, nitric acid affects the skin if it accidentally falls on it. Nitric acid has an extremely corrosive action on the skin and causes painful blisters. And the second effect is it combines with the protein of the skin, forming a yellow compound which is known as xanthoprotic acid, and hence stains the skin yellow. Okay students, so when we use nitric acid in lab, so after some time we can see that skin of our hand become yellowish. Why? Because the skin of the protein of the skin reacts with nitric acid and converted in the form of xanthoprotic acid. Okay students, then distillation for boiling cannot be used to concentrate nitric acid beyond a certain concentration. So after the preparation of nitric acid in osmosis process, we are using a distillation process to concentrate it, but beyond a certain concentration we cannot further concentrate that acid with the help of simple distillation or boiling. Okay, so by simple distillation or boiling, we can concentrate that acid up to 68% only. After that, it cannot be concentrated with the help of distillation or boiling, because the mixture of the acid at this concentration with water is forming a constant boiling mixture. Okay students, so a constant boiling mixture is one which boils without change in composition. Hence, on boiling, the above mixture evolves out the vapors of both acid and water in the same proportion, and that is why, due to the presence of same proportion of both the acid and water in the form of vapor, further concentration is not possible by distillation or boiling. Thus, dilute nitric acid cannot be concentrated beyond 68%. Further concentration of the acid is only possible by distillation under reduced pressure in the presence of concentrated sulfuric acid. This gives nitric acid about 98% purity. Is commonly known as fuming nitric acid. Okay students, so beyond 68%, if we want to concentrate nitric acid, we have to go through with the process of distillation under reduced pressure. Okay, so under these conditions, the mixture of acid and water will boil in such form that in the vapor condition there will be more amount of water in the mixture. So we can able to concentrate nitric acid after this concentration under reduced pressure in the presence of concentrated nitric acid. Okay, the next page. Properties of nitric acid. And the second point, chemical properties of nitric acid. So nitric acid, first properties: stability, action of indicators, and ionization of acid. So stability of nitric acid. First point, pure nitric acid is colorless and unstable and decomposes slightly even at ordinary temperature and in the presence of sunlight. The decomposition results in the formation of reddish brown nitrogen dioxide, which remains dissolved in the acid and imparting a slight yellowish brown color. So this point we have already discussed this. Then second point, at higher temperatures or after a prolonged period of time, the decomposition is complete and the acid turns a darker yellowish brown color due to the formation of NO2. The color of the acid can be removed by warming the acid around 60 to 80 degrees Celsius and bubbling air through it. And second point, thus concentrated nitric acid kept in plain glass bottles turns yellow or yellowish brown in color, and this is the reason we are using a brown colored bottle to keep nitric acid in lab. Then second heading, action of indicators on nitric acid. So moist litmus, blue to red, methyl orange, orange to pink, phenolphthalein, colorless to colorless. Then ionization of nitric acid. So dilute nitric acid ionizes in this way, and you can see here that hydronium ion is formed. So this hydronium ion is responsible for the acidic nature of dilute nitric acid. But in high concentration, the high concentration of H plus ions impart acidic nature to it. But a pure concentrated nitric acid is poorly ionized, and hence its oxidizing properties tend to predominate. Okay, it means that dilute nitric acid will behave as a strong acid and in the form of monoprotic acid, because per molecule it is evolving one H plus ion. Okay students, so that is why dilute acid is reacting with bases and salts in this way, forming a related compound with water and CO2. So with alkali it is forming salt plus water, neutralization reaction. With hydroxide, ferric hydroxide, ferric nitrate plus water. With calcium carbonate, it is forming calcium nitrate, water and CO2. So these all are the typical acidic properties which are performed by dilute nitric acid. But in the case of concentrated nitric acid, oxidizing properties are predominates. Okay, so concentrated nitric acid is behaving as a oxidizing agent. Next page. Nitric acid as oxidizing substance or oxidizing agent. So oxidizing nature of the nitric acid. The oxidizing property of nitric acid is based on the fact that when nitric acid undergoes decomposition, it is nascent oxygen. So the formation of or yielding of nascent oxygen, this nascent oxygen is responsible for the oxidizing nature of nitric acid, concentrated nitric acid. Okay students, so as you can see here that with concentrated nitric acid, copper get oxidized in the form of copper nitrate. Okay students, the nascent oxygen oxidizes non-metals, metals, inorganic and organic compounds. Nitric acid itself undergoes reduction in a number of ways. Hence, a number of reduction products like NO, NO2, N2O, etc. are formed in different reactions which depend upon the condition of the concentrated nitric acid and temperature and pressure, depending on the acid concentration and the temperature of the reaction.